Ever pondered over how data is stored and managed in large organizations? In our hyper-connected digital world, data is the lifeblood of any organization, big or small. It's the raw material that fuels decision-making, drives innovation, and propels growth. But have you ever stopped and wondered, where does all this data go? How is it stored, managed, and retrieved? Enter the world of databases. A database is a structured set of data. Imagine it as a super-organized digital filing system where all your data is neatly categorized and stored, ready to be retrieved at your command. It's like a library, but instead of books, you've got bits and bytes of data. Welcome to Data Lab Works channel. Now, databases come in various shapes and sizes, each with its unique strengths. Let's take a quick tour. First up, we have relational databases. These databases are all about relationships, as the name suggests. They organize data into tables, where each table is linked to another through a common key. Think of it like a family tree, but for data. Next, we have hierarchical databases. Picture a tree, with the main trunk branching out into smaller branches and then into leaves. Each branch or leaf represents a piece of data, all connected in a top-down hierarchical manner. Then there are network databases. These guys take the concept of relational databases a notch higher. They allow multiple records to be linked together through multiple paths. It's like navigating through a maze with multiple ways to reach your destination. Finally, we have object-oriented databases. These databases treat data as objects, each with its own properties and methods. It's like having a bunch of digital minions, each with its unique skills and traits, ready to answer your data queries. So in essence, a database is like a sophisticated digital filing cabinet, isn't it? Now that we know what a database is, let's delve deeper into its structure and components. Picture a database as a digital warehouse, a space where data is stored, organized, and managed. But what are the building blocks of this warehouse? The answer lies in tables, records, and fields. To understand how these elements work together, let's consider a real-world example. Imagine a library. Each book represents a record. The specifics of the book, such as its title, author, and publication year, represent fields. All these books or records, when grouped together by a common theme, say science fiction, form a table. In the database world, this is precisely how tables, records, and fields interact to store and manage data. Tables are the largest units, each containing a set of records. Records, in turn, are made up of fields. Each field contains a specific piece of information about a record. For instance, in a table of customer information, a record could be a single customer, and fields could include their name, address, and phone number. This structure isn't haphazard. It's meticulously designed to ensure efficient data management. A well-structured database is like a well-organized library. It's easy to find the book you're looking for. If our library or database were disorganized, we'd spend a lot of time searching for data, leading to inefficiency. That's why database design is crucial. It involves planning the structure of a database to support the information needs of an organization effectively. The goal is to reduce redundancy, maintain data integrity, and enhance data retrieval and performance. So the next time you perform a quick search on an e-commerce website or use an application, remember that a meticulously designed database is working behind the scenes, making your experience smooth and efficient. The magic of databases lies in their structure, enabling easy access and management of vast quantities of data. Ever wondered how professionals visualize a database's design? Meet ER diagrams. What's an ER diagram, you ask? Well, the ER in ER diagram stands for entity relationship. It's a graphical representation of entities and their relationships to each other, typically used in computing in regard to the organization of data within databases or information systems. So in essence, ER diagrams are a tool to visualize and describe the data relating to the major entities in the real world in a database. Let's break it down a bit more. An ER diagram consists of entities, relationships, and attributes. The entities are the things we need to store data about. They could be physical objects like a car or a person, or abstract concepts like an event or an idea. In the world of databases, entities are usually represented by rectangles. Next up, we have attributes. These are the properties or characteristics of an entity. For instance, a person entity might have attributes such as name, age, or address. Attributes provide more information about an entity's characteristics and are typically represented by ellipses. The final piece of the puzzle is relationships. These illustrate how two entities interact with each other. For instance, a person might have a drives relationship with a car. Relationships are usually represented by diamonds. So why are ER diagrams so useful? They provide a clear visual representation of the structure of a database. They allow us to see at a glance what kind of information a database contains, how that information is arranged, and how different pieces of information relate to each other. They're essentially a roadmap for the database, showing how all the different pieces fit together. They're invaluable for planning a new database or for understanding an existing one. In conclusion, ER diagrams are a powerful tool for visualizing and understanding databases. They help us see the forest for the trees, providing a high-level overview of a database's structure and relationships. Think of ER diagrams as a blueprint for databases, helping us understand the relationship between different data components. In our digital world, databases have become the backbone of IT. Let's explore why. Just imagine an orchestra without a conductor, or a ship without a compass. That's what an IT system would be like without a database. Databases are the unsung heroes of the digital realm, silently and diligently managing vast volumes of data. Starting off with data storage, databases are the warehouses of the digital world. They hold all the data that drives our websites, applications, and software systems. They store everything from user profiles, transaction records, to product listings, and much more. This organized storage allows easy access to and retrieval of data, ensuring that the right information is available at the right time. Moving on to data management, databases are not just about storing data, they're also about managing it efficiently. They ensure data consistency, integrity, and accuracy, which are crucial in maintaining the quality of data. They also handle tasks such as data backup and recovery, allowing organizations to safeguard their valuable data against loss or damage. In terms of data security, databases are the fortresses that protect valuable data from unauthorized access and potential threats. They offer various security measures, such as access controls, encryption, and auditing, ensuring that data remains secure and confidential. But perhaps the most significant aspect is how databases facilitate data analysis. They enable organizations to sift through vast amounts of data, identify patterns, and derive insights. This data-driven decision-making is a game changer, helping businesses to optimize their operations, enhance customer experiences, and stay competitive. In short, databases are the lifeline of IT systems. They are the central hub where data is stored, managed, secured, and analyzed. They are the pillars that support the structure of our digital world, quietly ensuring that everything runs smoothly and efficiently. Databases, therefore, aren't just storage units. They are strategic assets in the IT world. So, how do we interact with databases? Through database management systems, or DBMS. This is where we step into the world of software that allows us to communicate with these vast data repositories. A database management system, fondly abbreviated as DBMS, is like the ringmaster in a circus of data. It controls, manages, and navigates the chaos, bringing order to the apparent disorder. It's through a DBMS that we can create, retrieve, update, and manage data, making it an essential tool in the world of information technology. Several popular DBMS options are available, each with its unique features and benefits. Let's take a quick tour through some of them. First up is Oracle, a behemoth in the world of database management. Known for its robustness and versatility, Oracle is often the go-to choice for large corporations handling massive amounts of data. Next, we have MySQL, a free and open-source DBMS. It's a favorite among web developers owing to its compatibility with numerous web-based applications and ease of use. Then there's SQL Server, a product of tech giant Microsoft. SQL Server is lauded for its comprehensive security features and scalability, making it a preferred choice for businesses of all sizes. These systems serve as a bridge connecting users and applications with the database. They provide a user-friendly interface, allowing us to tap into the power of databases without needing to navigate the complex, underlying structures. In conclusion, databases are the unsung heroes of our digital world. They are the custodians of information, the record keepers of our digital age. And it's the DBMS software that allows us to harness the full potential of these data repositories. Data is the new oil, and databases are the refineries that make this oil usable. So, the next time you use an app or visit a website, remember, there's a database working behind the scenes. If you had enjoyed the video, kindly hit the like button. If you had not already subscribed to my channel, kindly subscribe to get updates on time. Hit the notification bell to get notified on time. Thank you. Until next time, take care.